Hey everyone, welcome. If you have a React interview coming up today, tomorrow, this week, this video is built specially for you. During the video, we're going to cover every core concept that interviewer will expect you to understand, and then go through 20 actual interview questions with the kind of answer that show you know what's happening under the hood, not just how to make things work. I'll be showing code on screen the whole time. Pause whenever you need to. There's a lot here and I want you to actually absorb it, not just watch it. Here is the structure. First half is concepts, about 18 of them. Second half is interview questions, to understand why the answers are what they are. Watch the concepts first, they build on each other. One thing before we start, React is a library, not a framework. It renders UI. Everything else, routing, state management, data fetching, you bring in yourself. Keep that mental model with you throughout this video. Alright, clock running, let's go. Components. Everything in React is a component. A component is a JavaScript function that returns JSX, a reusable self-contained piece of UI that can have its own logic, its own state, and its own styling. Modern React uses functional components exclusively. If you're looking at code base that use class components everywhere, it's either legacy code or it hasn't been touched in few years. The most useful mental model for organizing components is the split between presentational and container components. Presentational components receive props and render UI, nothing else. Container components hold logic and state, and pass data down. You don't need to enforce this a hard rule, but keeping these two concerns separated makes your codebase dramatically easier to test and reason about. One component, one responsibility. That's the guiding principle. JSX. JSX is the syntax that looks like HTML inside your JavaScript files, but I want to be very clear, it is not HTML. It compiles down into React create element calls before it even reaches the browser. This matters because JSX has different rules. You use class name instead of class, you use HTML4 instead of for on label elements. Every tag must be explicitly closed, even self-closing ones need a slash. And any JavaScript expression goes inside curly braces. If you need conditional rendering, you can't use an if statement directly inside JSX. You use a ternary operator or short-circuit evaluation with double ampersand. If a component returns nothing under some condition, return null explicitly. JSX is technically optional. The React Create Element API works without it, but nobody writes React that way because JSX makes the structure of your UI immediately readable. Props. Props are how components communicate. They're the inputs parent passes to a child, and the fundamental rule is this. Props are read-only. A child component can never modify the props it receives. This enforces unidirectional data flow. Data moves in one direction, from parent down to child. When a child needs to communicate something back up, it goes through a callback function that the parent passes down as a prop. Data down functions up. That's the pattern. One important concept here is prop destructing. Instead of writing prop's name, prop's role throughout your component, you destructure in the function signature. It's cleaner and makes the component interface immediately obvious. Default props gives you fallback values. TypeScript props types gives you compile time safety. Both are worth knowing. State and useState. State is local mutable data that lives inside a component. The critical difference between state and a regular variable is this. When state changes, React renders the component and updates the UI. A regular variable change does nothing on its own. React has no way to know about it. You declare state with the useState hook. It returns a tuple, the current value, and a setter function. To update, always use the setter. Never mutate the value directly. Direct mutation won't trigger a re-render. Two things that trip people up. First, state updates are batched in React 18. Multiple set state calls in the same event handler are grouped into a single re-render. This is a performance optimization. Second, if your new state value depends on the previous state, use the functional update form. Pass a function to the setter that receives the previous value and return the new one. This avoids tail closure bug when updates get batched. State should be as close as where it used as possible. Don't lift it higher than necessary. useEffect. useEffect is how you run side effects in a functional component. A side effect is anything that reaches outside the rendered cycle. Fetching data, subscribing to a WebSocket, starting a timer, writing to a local storage, directly manipulating a DOM. The hook takes two arguments. First, a function containing your effect. Second, a dependency array. This is what controls when the effect runs. Empty array runs once after mount, equivalent to component did mount. Array with values runs whenever any of those values change. No array at all runs after every single render. Almost never what you want, and a common source of infinite loops. The cleanup function is what most developers get wrong. If your effect creates a subscription, event listener, or timer, you must return a function that cleans it up. React calls that function before the next effect runs and when the component unmount. Skip the cleanup and you have a memory leaks. One rule of thumb: each effect should do one thing. Multiple useEffect calls in one component is completely normal and preferred over the giant effect that does everything. useRef. useRef gives you a mutable container that persists across renders without causing your renders when it changes. This is the key difference from state. Updating a ref doesn't trigger a render. The two main use cases: accessing DOM elements directly and storing mutable values that you want to persist across renders, but don't want to trigger a render when they change. For DOM access, attach the ref to an element via the ref attribute, then read ref current to get the actual DOM node, useful for managing focus, reading scroll position, or integrating with non-React libraries. For mutable values, think of it as an instance variable, storing the previous value of a prop, tracking whether a component is mounted, holding a timer ID. All of these are ref use cases, not state. Virtual DOM and reconciliation. React maintains a virtual DOM, a lightweight JavaScript tree that mirrors the structure of a real DOM. When state changes, React doesn't immediately update the actual DOM. Instead, it builds a new virtual tree, diffs it against the previous one, and computes the minimum set of changes needed. Then it applies only those changes to the real DOM. This process is reconciliation. This is what makes React fast. DOM operations are expensive. By batching and minimizing them, React reduces the performance cost of UI updates. The key prop is part of this system. When you render a list, React needs a stable identifier for each item so it can match nodes between the old and new trees. Without keys, React matches by position, which breaks when items are added, removed, or reordered. Use stable IDs from your data, never array indexes or dynamic lists. Context API. Context solves the prop drilling problem. Prop drilling is when you pass data through layers or intermediate components that don't actually need it. They're just passing it along to something deeper. With context, you create a context object, wrap part of your tree in its provider, and any component inside that tree can read the value directly with useContext, without any props being treated through the middle. Context is the right tool for genuinely global low-frequency data: the current user, the active theme, the user's local settings. Things that many components need to read but that don't change on every user interaction. The important caveat: every component that consumes the context will render when its value changed. This is why contexts are poor fit for frequently updated state. You trigger re-renders across the entire consumer tree on every update. For that, reach for a dedicated state management library. A useReducer. useReducer is useState's more powerful sibling. Where useState is ideal for simple independent values, useReducer shines when you have complex state logic, multiple subvalues that change together, or when your next state depends on the previous state with non-trivial ways. The pattern is the same as Redux. You define a reducer function that takes the current state and an action, and returns the new state. You dispatch actions to trigger state transitions. The advantages. All your state logic lives in one pure function that's trivially easy to test. The state transitions are explicit and named. Complex form, multi-step wizards, shipping cards, these are all good useReducer candidates. A common pattern is combining useReducer with context to create a lightweight global store, essentially Redux without the external dependency. useMemo and useCallback. Both hooks are about memoization, caching a value so it's only recomputed when its dependencies change. useMemo memoizes the result of a computation. Use it when you have an expensive calculation, filtering, or sorting a large dataset, running complex derived logic, and you don't want it running on every render. useCallback memoizes a function reference. In JavaScript, a new function object is created on every render. If you pass that function as a prop to a memoized child component, React.memo sees a new reference under render anyway. useCallback gives you a stable reference across renders. React.memo wraps a component and prevents it from re-rendering if its props haven't changed with a shallow comparison. The rule. These are optimization tools. Don't use them by default. Add them when you have a documented performance problem. Premature memoization adds complexity and can actually worsen performance by adding overhead. Custom hooks. A custom hook is a JavaScript function whose name starts with use and that calls other hooks internally. The naming convention is required. It's how React's linter and tooling identify it as hook and enforce the rules of hooks. The purpose of custom hook is to extract and share stateful logic across components. No UI, just logic. The same way you extract repeated function into utilities, you extract repeated hooks patterns into custom hooks. The signal that you need one, you're copying the same useState, useEffect combination into a second component. That's the moment to extract. Good examples to know. Use fetch for data fetching, use debounce for debouncing input values, use local storage for persisted state, use onClick outside for drop-down dismissal, use Windows sites for responsive logic. Error boundaries. Error boundaries are a React mechanism for catching JavaScript errors during rendering and showing a fallback UI instead of crashing the entire application. They are class components, there's no hooks equivalent yet, though libraries like React Error Boundary wrap the class API into a cleaner hook-based interface. The critical limitation. Error boundaries only catch errors that occur during rendering, in lifecycle methods and in constructor of child components. They do not catch errors in event handlers, async code, or server-side rendering. For those, use regular try-catch and manual error state. Wrap each major feature or route in its own error boundary. This way, if one part of the app crashes, the rest continue to work. Log count errors to a service like Sentry in component did catch. React Router. React itself has no routing. React Router is the standard library for adding client-side navigation to React applications. The core concepts. You define routes by mapping URL path to components. The router wraps your application and keeps the URL in sync with the render component tree. Browser router uses the HTML5 history API and is what you use in production. Hash router uses URL hashes and requires no server configuration. The hooks you'll use constantly: use navigate for programmatic navigation, use params to read dynamic route parameters, use location to access the current URL, and use search params to read and update query string parameters. Route-based code splitting with React Lazy is essentially free with React Router. Each route gets its own bundle chunk, loaded only when the user navigates to it. Data fetching and React Query. Fetching data in useEffect works, but it has real problems. You manually manage loading state, error state, caching, and race conditions. As your app grows, this boilerplate multiplies. React Query, now Tunstack Query, is the standard solution for server state management in React. Server state is fundamentally different from UI state. It lives remotely, can be stale, and needs to be synchronized. The use query hooks gives you automatic caching, background refreshing, deduplication of identical requests, loading and error states out of the box, and stale while revalidate behavior, all with essentially no boilerplate. Use mutation handles create, update, delete operations and integrates cleanly with query invalidation, so your UI stays in sync after mutations. The mental model shift. Stop thinking about fetching as a side effect and start thinking about it as synchronizing with a remote data source. React Query manages that synchronization for you. Performance optimization. Let's talk about performance in a systematic way, because randomly shrinking useMemo and useCallback anywhere is not a strategy. Start with measurement. React DevTools has a profiler tab that records, renders, and shows you exactly which components are re-rendering, how often, and why. Use it before optimizing anything. The highest impact optimization in order. First, code splitting with React Lazy. Don't ship code the user doesn't need. Second, virtualization for long lists. If you're rendering hundreds of thousands of items, only render what's visible in the viewport. Libraries like React Window or Tunstack Virtual handle this. Third, memoization. React.memo, useMemo, useCallback, but only for components or computations that are probably expensive. Fourth, avoid anonymous functions and object literals as a props to memoized components. They create new reference on every render. State architecture matters more than any of this. Keep state local, avoid putting everything in the top level, and consider state splitting to reduce the blast radius of updates. Portals. A portal lets you render a component output into a different DOM node than its parent, outside the normal React component tree. The classic use case is modals, tooltips, and dropdowns. The problems they solve: CSS overflow and z-index. If your modal is nested inside div with overflow hidden, it gets clipped. If it's inside a stacking context with a lower z-index, it can appear behind other elements. Portaling to document body puts the modal at the top level of the DOM, completely outside any stacking or overflow context. Despite rendering outside the DOM hierarchy, portals still behave like normal React children. Events bubble up through the React tree, not the DOM tree. Context works normally across portals. Suspense. Suspense is React mechanism for handling asynchronous operation declaratively in the component tree, letting you specify a fallback UI while some part of the tree is waiting. The most common use today is with React Lazy for code splitting. You wrap a lazily loaded component in a suspense boundary, and React shows the fallback while the chunk is loading. The more powerful use and the direction React is heading is data fetching. With React 18's Suspense for data fetching, a component can suspend while its data loads, and the nearest suspense boundary handles showing a skeleton or spinner. Libraries like React Query and Relay supports this model. The mental model. Instead of each component managing its own loading state with useState booleans, loading states are handled at the boundary level, declaratively in JSX, where you can see them. React 18 concurrent features. React 18 introduced concurrent rendering, the ability for React to work on multiple state updates simultaneously, pause and resume rendering, and prioritize urgent updates over non-urgent ones. The two hooks you need to know. Use transition marks a state update as non-urgent. React will still process it, but it won't block the browser from handling higher priority updates like user input. The is pending flag lets you show a loading indicator during the transition. Use deferred value accepts a value and returns a deferred version of it. React delays updating the deferred value until the browser is idle. Useful for keeping input fields responsive while expensive derived renders catch up. These tools let you keep your UI responsive under heavy computation load, without compromising the user experience on fast interactions. Alright, concepts done. Now let's go through 20 interview questions. Same format as before. I'll give you the question, a solid answer, and what the interviewer is actually listening for. This escalates in difficulty. The first few are fundamentals that everyone gets asked. By the end, we're in territory that separates mid-level from senior.
What is the difference between state and props?
Props are inputs passed from parent to child, read-only owned by the parent.
State is local data owned and managed by the component itself, mutable via the setter function. The mental model: props are like function arguments. State is like local variables inside the function that persist between calls. What the interviewer wants: that you understand ownership.
Props flow down are immutable from the child perspective. State is private to the component and triggers re-renders when updated.
What is the difference between controlled and uncontrolled components?
A controlled component has its form data managed by React state. Every keystroke fires on change, which updates state, which sets the input's value. React is always the single source of truth.
An uncontrolled component lets the DOM manage its own data. You access it via the ref when you need it, on form submit for example. Controlled is idiomatic React. It gives you live validation, conditional formatting, and ability to disable submit until the form is valid. Uncontrolled is simpler and can be useful for file inputs or when integrating with non-React code.
The interviewers want you to know who owns the data, React or the DOM.
What causes a component to re-render?
Three things cause a component to a re-render: its own state change, its props change, or its parent re-renders, even if none of the child props changes.
That third one is what people miss. Apparent re-rendering is a re-render trigger for all children regardless of what props they receive. What they want: you know all three causes.
The follow-up with almost certainly. B. How do you prevent unnecessary render? React.memo, useCallback, useMemo, moving state down.
Explain the useEffect dependency array in detail.
The dependency array tells React when to run the effect. React compares the current value in the array to the previous value after each render, using object isEquality. If any value changes, the effect runs.
Empty array, effect runs once on mount. No array, effect runs on every render. Array with values, effect runs when those values change. The common mistake is missing a dependency, putting something in the effect but not in the array. This creates tail closure bugs when the effect reads an outdated value. The exhaustive depths ESLint rule catches this.
What they want: you understand the comparison mechanism and the state closure problem.
What is the difference between useEffect and useLayoutEffect?
Both run after React renders, but at different points in the browser pipeline.
useEffect is asynchronous. It fires after the browser has painted the frame. useLayoutEffect is synchronous. It fires after React updates the DOM but before the browser paints. Use useLayoutEffect when you need to read or modify the DOM before the user sees it. Measuring elements' dimensions and repositioning based on that measurement is the canonical example with useEffect. The user sees the pre-adjustment position for one frame.
What they want: you know this distinction exists and you know exactly when it matters. Most developers use useEffect for everything. Knowing the difference shows depth.
What is reconciliation and how do keys affect it?
Reconciliation is the process React used to diff the new virtual DOM tree against the previous one and compute the minimal set of real DOM changes.
React uses a heuristic algorithm that's O of n rather than O of n cubed. It makes assumptions to keep diffing fast. One assumption: elements at the same position in the tree with the same type are considered the same element. Keys override position-based matching for list items. A key tells React, this item has this identity, regardless of where it appears in the list. Without stable keys on dynamic lists, React may reuse the wrong DOM nodes, apply updates incorrectly, or lose local component state.
What the interviewers want? They want you to understand reconciliation, not just React need keys.
Explain context. When should you not use it?
Context provides a way to share values down the component tree without prop drilling. You create a context, wrap a subtree in its provider, and any descendant can read the value via useContext.
Context is the right choice for generally global low-frequency data. Out status, theme, local. You should not use context as a general-purpose state management solution for two reasons. First, every consumer re-renders when the context value is changed. For frequently updated state, this means unnecessary renders across the tree. Second, context has no optimization primitives, no selectors, no subscriptions.
What the interviewers want? They want you know what context is designed for and where it breaks down.
When would you use useReducer over useState?
useReducer is preferable when state logic is complex, multiple subvalues that need to update together, state transitions that are non-trivial, or when the next state depends on the current state in complex ways.
The practical benefits. Your state logic lives in a pure reducer function that you can test in isolation without rendering a component. State transitions are explicit and named. Reading the action names tells you exactly what can happen to the state. A good heuristic. If you find yourself writing multiple useState calls that always change together, it's probably time for useReducer.
What they want? A concrete mental model for when the trade-offs make sense.
What is prop drilling and what are all the solutions?
Prop drilling is passing props through intermediate components that don't need them, just to get data to a deeply nested descendant.
The solutions in order of reach. Component composition. Pass components as children rather than data. Often eliminates the need to pass data at all and is underused. Context API for genuinely global data that many components need. State management library. Redux, Dustand, Jetai when context render behavior is a problem, or you need features like selectors and middleware.
What they want? You know all three solutions and can reason about which fits which situation. Composition being first shows architectural maturity.
What is code splitting and how do you implement it?
Code splitting divides your JavaScript bundle into smaller chunks that loads on demand instead of all at once up front.
Users only download the code for what they're actually using. In React, React Lazy for dynamic import is the built-in mechanism. You wrap the import in Lazy, wrap the component in Suspense with a fallback, and the chunk downloads only when that component first renders. Route-based splitting is the highest ROI application. Each major route gets its own chunk. With React Router, each route component becomes a lazy import.
What they want? You think about what you ship to user, not just whether thing works.
What is the React Fiber architecture?
Fiber is the internal reconciliation engine. React wrote in version 16. The key innovation, rendering work is now incremental and interruptible.
Before Fiber, React would walk the entire component tree synchronously in one pass. No pausing, no interrupting. On large trees, this blocked the main thread and dropped frames. Fiber breaks rendering work into small units. React can process some units, pause, handle a higher priority update, then resume where it left off. This is what makes concurrent features like use transition possible.
What they want? You know Fiber exists and understand it as the foundation for concurrent rendering, not just trivial answer.
What are the rules of hooks and why do they exist?
Two rules. First, only call hooks at the top level, never inside conditions, loops or nested functions. Second, only call hooks from React functional components or other custom hooks.
The reason: React identifies hooks by their call order. Every render must call hooks in exactly the same sequence. If you conditionally call a hook, the call order changes between renders and React associates the wrong state with the wrong hook. The order is everything. React doesn't identify hooks by name. It identifies them by position in the call sequence.
What they want? You understand the mechanism, not just the rule.
How does React.memo work, and what are its limitations?
React.memo is a higher-order component that memoizes a functional component. If a parent re-renders but passes the same props, React keeps re-rendering the memoized child.
The comparison is shallow. For objects and arrays, it checks reference equality, not deep equality. This means a new object's literal passed as a prop always fails the check, even if its contents are identical. For objects and arrays as props, you need useMemo on the parent side to stabilize the reference. For functions, use callback. React.memo accepts an optional second argument, a custom comparison function, for cases where you need deep equality or custom logic.
What they want? You know the shallow comparison gotcha and how to handle it.
How do you handle forms in React?
Forms in React work through controlled component. Each input value is bound to state variable via the value prop, and on change updates the state on every keystroke.
React is always the source of truth. For complex forms, multi-steps heavily validated many fields, a library like React Hook Form or Formic gives you performance optimization, uncontrolled inputs under the hood, and built-in validation integration with schema libraries like Zod.
What they want? You know the controlled pattern and know when to reach a form library. For simple forms, DIY. For complex forms, use a library.
What is lifting state up?
Lifting state up means moving state to the nearest common ancestor of the components that need to share it.
The ancestor holds the state and passes the data and any update callbacks down as prop to the children that need it. This is React idiomatic solution for sibling-to-sibling communication. You never have siblings communicate directly. You go through the parent.
What the interviewers want? Clean articulation of the pattern and why it enforced unidirectional data flow.
How do you handle async operations and race conditions in useEffect?
The race condition. If a component fetches data when an ID prop changes, and the user changes the ID quickly, multiple fetches can be in flight simultaneously.
The last one to resolve wins, which might not be the most recent request. The solution is cleanup. In the effects cleanup function, cancel the in-flight request using abort controller. When the ID changed, the previous effect cleans up, aborting the stale fetch before the new one starts. React Query handles this automatically, which is the one of its underappreciated advantages.
What they want? You thought about async edge cases, not just the happy path.
What testing approaches do you use for React components?
The standard stack is Jest for the test runner and React testing library for components tests. RTL's philosophy: test what the user sees and does not internal implementation details.
Query by accessible role, text content or label, not by class names or component structure. Unit test per functions or custom hooks. Integration test component interactions. For end-to-end test, Playwright or Cypress. The guiding questions for every test. If I refactor this component without changing its behavior, does the test still pass? If not, you're testing implementation details.
What they want? RTL philosophy: behavior over implementation. Knowing this separates developers who understand testing from those who just write tests.
What is server-side rendering and how does Next.js relate to React?
React by default is client-side rendering. The browser downloads an empty HTML, shell and JavaScript. React run in the browser, and the UI is built client-side.
Server-side rendering generates the full HTML on the server on each request. The user sees content immediately without waiting for JavaScript to execute. Better time to first byte, better SEO, better perceived performance. Next.js is a React framework built on top of React that adds routing, SSR, static generation, API routes, and with the app router, React server components.
What they want? You understand the rendering spectrum and where Next.js fits.
What are React server components?
React server components run exclusively on the server. They can directly access databases, file systems, and server resources without any API layer.
Their output, a serialized component description, is sent to the client, not the JavaScript bundle. The key distinction from SSR: RSCs don't need their JavaScript to the client at all. The component code stays on the server. This means zero bundle impact for data fetching logic. They cannot use state effects or browser APIs. For interactivity, you compose them with client components, marked with the used client.
What they want? You understand the server-client component boundary and why RSCs reduce bundle size.
How would you architect a large React application?
This is an open-ended question. There is no single correct answer. But here's a defensible approach that shows architectural maturity.
Feature-based folder structure rather than type-based. Components, hooks, and utilities grouped by feature, not all components in one folder. Clear data flow, React query or SWR for server state, useState or Redux toolkit for complex client state, context only for low-frequency global values. Strict component boundaries. Co-locate related logic, extract custom hooks early, keep components focused. Performance by default, route-based code splitting, virtualization for long list, error boundaries around each major feature. Testing strategy, RTL for component behavior, custom hook test with render hooks, playwright for critical user flows.
What they want? You think in systems, not components. Architecture is about managing complexity as the code base grows, and you talked about it. And that's all. 18 concept, 20 interview questions. If you got through all of that, here's the honest truth. Most candidates won't know half of what we covered today. Not because they're bad developers, but because a lot of this knowledge comes from hitting specific problems in productions, not from tutorials. The fact that you're watching this, taking it seriously and preparing, that already puts you ahead. For the interview itself, don't just give the answer, explain the why. Interviewers at good companies are listening for your reasoning, not just memorize definitions. Subscribe if you want more of this. More videos like this about other technologies are coming next. Go get the job and good luck!